Hello ladies and gentlemen, it's Mike here at Game From Scratch, and today we are looking at global illumination. Specifically, how do you handle global illumination in the Godot game engine? And the answer to that is GI.Probes. And I kind of covered this a little bit, kind of, in yesterday's tutorial. Yesterday I did an ad hoc tutorial on basically implementing simple scenes in Godot. 3D scenes, how to set up the lighting, and so on. But one thing I really glossed over was GI.Probes. So that's what we are going to fix today. This is going to be a quick and dirty tutorial showing you how to use global illumination in the Godot game engine. If you're interested in checking out yesterday's video, I will link that down below. I'll also probably do a short text-based tutorial of what we're going to cover today also. So if you want to see how to do things step by step, don't worry, I will cover that in a link below as well. All right, so first off, let's head on over to Godot. Now, first thing is, global illumination sounds scarier than it is. In the world of Godot, or the world of game engines in general, you have pretty much three kinds of light. You've got ambient light, that is the light that's kind of all around us. You've got direct lights. Think about that. When you throw a light in the scene, like this guy right here, there's this Omni spotlight in the scene, that is a direct light. It is lighting the world, sending light all out in all directions and lighting scenes up. So you can see the shadows that it's generating, the lighting on this surface right here, that is direct light. Now, the reality is, though, that's just not the way the world works. So we've got this light here in our scene. We can see it right there. We're inside of a box. So there you see the scene. And over here, complete darkness. Over here, complete darkness. That is not the way reality works at all. The truth of the matter is light bounces. Light bounces off surfaces, and the way that it bounces off of those surfaces kind of determines the coloration and the shadow on the receiving surface. And that is where global illumination comes in. Global illumination can be thought of as secondary light sources, things like bouncing, but it's also part of emissive light, that we will get to in just a second. So here again, you can see a simple scene. I've set up a mesh. I flipped the normals on it so that it's inside out. And then I set up another mesh inside so we can actually see some shadows going on. And then I created this light. But then I also created a GI probe. And right now you'll notice that it's currently hidden. A GI probe, let me just turn it back on, is like a volume. This is the area inside of a map that is going to have global illuminations calculations done on it. And the GI probe is what does all the calculating. Now you need to set up a volume for each area on your map. So you can have, by the way, having multiple GI probes that overlap is completely and utterly useless. But if you want to have different areas where you want to have global illuminations, but other areas on your map where you don't need it, you only set up your GI probes where you need them. You can create multiple GI probes, by the way. And what you've noticed here is when I've turned it on or off, the effects are turned on or off as well. If you want to hide this bounding box, what you instead do is go up to View, and then you go and turn off GI probe. So then it'll still be active, but it won't be visible. So with it turned off, so let's go back into our world. Let's look at the effect of this GI probe. So again, GI probe off, the light goes out, and then in the back here, you get no bounced light. Nothing bounces off this back wall, and it's not really realistic to the world. GI probe on, and then boom, see, you're getting secondary lighting. And not only that, but the surface material, the actual material the light bounces off of, is helping to determine the shadow color. So here you're getting some kind of a reflection in addition to secondary lighting. On top of that, there's also reflection probe. So if you want to get more detail on the reflection, if your one surface is more mirrored, you can also set up a reflection probe, but I'm not getting into that in this video. If you need that, let me know. Maybe I'll do a video about it as well. But reflection probes are pretty straightforward, to be honest. So that is the one purpose of a GI probe. What it does is it does additional lighting calculations in the world. It's doing a lot of voxel math stuff behind the scenes, and it's determining that this light goes out, it hits this wall. That would be the normal way of doing it, but GI probe also determines how it bounces, and so you do get these more realistic lighting conditions. So essentially, that is what global illumination is all about. I'll show you how to set this up in just a second. It's really simple, to be honest. But the other thing that it's about is emissive light sources. So here you can see, once again, we've set up a world. We have our GI probe all the way around the outside. And then what I've done is I've created this neon light. And you can see we've got a shadow going on from, we've got a light source here, and we've got a shadow going on from it. So turn the Omni light off. There we're only being lit by emissive light. So you see the light is working along with our emissive light, but you see this red going along the outside. Oops, turned off the wrong thing. That red light there, that's all coming from the emissive light source on this guy. An emissive light source is is basically your way of saying that this model gives off light. It's done via texturing. So I'll open this guy up for a second. So this is the neon sign. It's configured. Let me just open it up as a scene. It is configured as an emissive source. So we're going to go into the material for it. You scroll on down, you'll see it is emissive. Emissive is on. It's red, and then the energy level of the emissive, so the amount of light being emitted. So if we get to jack this way down, so it's got a lot less, and then we head back on over to our scene, the end result, you get a lot less light in the end. But I'm actually going to show you that in action. So I actually don't think I saved that, but we'll leave that as it is. So flip on back over here. I don't know if I have to, I don't think I have to bake the lights to update that, but let me just go ahead and do a bake of the lights. Oh yeah, you do have to bake the lights. All right, so see, when our emissive source is so much lighter and we've recalculated using our GR probe, you'll see the amount of emissive light goes way back down. So I'm going to go back up here, back in, turn the emissive energy back way up. So we got, see our neon sign is super neon now. We'll head back over to our scene, select our GI probe, rebake the lighting. And then there you see a whole lot more emissive going on. Now this is a secondary way of lighting your scene. So basically via the texture, you can give off colored lights from your textured objects. And you might be wondering, hey, well, what about all this versus light mapping? So light mapping is another option. What's the difference between GI and light mapping? Well, light mapping is faster, it's simpler, and it's also baked. And that's the downside there, is you can't move light mapped light sources around. You have to kind of pre-calculate them, whereas this can actually be calculated dynamically and on the fly. All right, so back to the whole dynamic, sort of the emissive lights that we've got going on here. I've actually set this guy up with a couple of very simple scripts. So attached to this guy right here, I've created some code. Come on. Show me. Anyways, I've created this code that when I press the Q and W keys, we increase and decrease the amount of emissive energy. And then when I press the space key, we bake our scene. And you don't really want to bake the lights in runtime if you can help it. You can. So if you change a light source, you have to rebake the scene to get the light to update. So let's head on back over to 3D view. All right, and back to our scene. Let's go ahead and run this guy. All right, so here you can see our scene running. I'm just going to hit Q a couple times to get the light level down. So we're going to make this guy a little bit dimmer, and then we're going to hit spacebar and bake the lighting. And then you see it's getting dimmer. It's giving off less light. Go down a little bit more and hit it again. Once again, you get the same thing. And you'll notice the bake isn't taking an extremely long period of time, but it's not something you want to do real time. You can do it between level loads. You could do it if you did like a minor update, but it's not something you're going to want to do on a per frame basis. So now I'm jacking it back up. And there you see the end result. So let's just go way on the emissive side. So I'm really cranking her up. And there you see it, more and more brightness. Now what you find is the amount of light given off from an emissive source seems to be a lot lower than the amount of light given off of like a primary light source. So you really got to crank these values up to get the end results you want. But you can see as I'm going, now I'm going to start going back dim again, really dimming things down, update. And I'm going to hold this guy down for quite a while to the point where we basically have no more lights on this guy. So we're going to see, eventually he's going to start dimming out. Come on. I don't know how high I actually got that number up. So we're way dimmer, and then a little bit more dimmer, and then eventually it's going to be transparent, and we're going to get no light at all. So as you can see, what this shows you is the GI probe is responsible for calculating emissive light. The emissive light is not a dynamic light, whereas if you go back over to the world of direct light that we've got here, so the GI probe is responsible for the secondary light bouncing like that we're seeing going on here. But in this case, and this is where it's different than shadow map or baked lighting, is the lighting actually is dynamic. So emissive lights are not dynamic either way, but when it comes to GI probes, when you have lights like this, when you move them around, they are dynamically updated. So you do get this secondary shadow, and the secondary shadow or the secondary reflections are, secondary lighting are reflected, pun not intended, when you move things around in the scene. So when we move this lighting around, and that is probably the biggest difference other than quality between this and baked light maps. So in case you're wondering what the difference between the two is, that is the big one there. So those are the two things that you've got for indirect lighting a GI probe does. So it calculates the secondary bounce lighting like this. So once again, no GI probe, crappy lighting. GI probe, better lighting. And then on top of that, it does emissive lighting like this, but again, emissive light sources cannot be moved around the scene. Now, I've said earlier on, I'll show you how to go ahead and create this guy, and it couldn't be easier, to be honest. So it seems like a daunting thing to do, but realistically, all you do is you have your meshes in the world. If they are part of the emissive light simulation, you basically just come into the material category and say, used in bake lighting on. Ditto for this guy, used in bake lighting on. You create yourself a GI probe. You have one or more light sources. You don't need to do anything to the light sources, by the way. And that's it. That's really all you need to do. The last thing, of course, is you need to define the GI probe's volume. So when you create it, you notice there's a set of little dots on it that you can use to scale it. You don't want to scale it to fit your scene pretty much as tightly as possible. And that's kind of the extent of it. On top of that, there's a number of different settings. You're going to want to play around with these only if your scene kind of demands it. Most of the stuff really isn't going to matter that much, except for perhaps the subdivisions. If you want to have more fidelity here, you can jack this up, but it's going to cost you. So if you want better lighting quality, you basically can increase the subdivisions, but that's going to cost you in terms of performance. Whereas if you also want lower, if you're fine with a reduced amount of quality, you can drop it down to the 64 subdivisions, and that will obviously make things faster, but uglier. So that is, man, it's hard to see when you've got the GI probe there. And then the only remaining thing you do, once you've set your GI probe in the world, is you bake your GI probe, and that does all the calculations. It takes all the angles and the lighting and all of that stuff, and it saves it up for you so it can be used real time for, again, if you move your light source around the world, that information and that data is all cached in the GI probe. So when you move your lights, it can do the updates. It can make everything look all shiny and good. The only real final thing to be aware of when it comes to this is if you care about the quality, if you want to get even better, because again, global illumination is an expensive calculation. So if you're on mobile, this isn't going to work. Specifically also, I should have mentioned this off the hop, it doesn't work at all on the GLES2 renderer. So you need to use the GLES3 to get global illumination. But if you're interested in increasing the quality, go into the project settings, go to quality, and then what you're looking for is the voxel cone tracing. You can turn that on right here, and you'll notice immediately the impact over here. I don't have a really advanced scene, but you see you're just getting better lighting, better banding across it, and so on. And that's it. That is, in a sense, global illumination in the Godot game engine. It's not rocket surgery by any means, but hey, now you know. And as they say, knowing is half the battle. So if you have any more questions about this, do let me know. I will try to follow them up with a tutorial like this one. Obviously, I can't spend all of my time doing one-to-one tutorials, but this honestly is an area where I 100% glossed over it. And I think global illumination or GI probes are scarier looking than they actually are. So it's one of those things that out of the box, sorry Godot, but your lighting is kind of terrible. But with just a little bit of tweaking and working, you can make Godot scenes look so much better than what you start with. And a GI probe and global illumination is a big part of that. And as you saw from this video, it's actually not that hard. So that's it. Hopefully you found that useful, and I will talk to you all later. Goodbye.